Hello and welcome to Tech of the Day. Today I'm going to start a new series which is data structures and algorithms. This is really important series for any developer who really wants to develop their core, his or her core actually. For any software engineer who really wants to understand um, and in his or her daily working life um, how to use the best data structure for their application, and that can really affect their application. Also the big companies like Google, Microsoft, Facebook, Amazon, they really focus on these two things. They don't care which programming language you are using, let's say C sharp, Java, Python, PHP. They don't care. They just want you to know these basic things, and then they are quite confident then you can pick up any language, because language is just a syntax. So let's start about me. I'm Nitesh Sharma, software engineer, really enthusiastic about software engineering and sharing knowledge, learning from each other. And I'm also certified Azure Solutions Architect and Azure DevOps expert, which you have other. For that, I have other playlists, other series. Now I'm focusing on this part. Let's continue. What is data structure? Data structure is simply just a form of representing a type of specific data into any predefined or structure. So let's say you have a data collection of let's say 100 or 1000 integers or numbers. Let's say simple 1000 numbers. How will you store them so that you can perform some of the operations at quick as possible, or depends what type of operations you want to perform. Maybe you just want to add new things, then this might be a good idea. It might be a good idea to have them stored in a different data structure. Then if you just want to get them at as quick as possible, let's say dictionary. So if you store any key value pair in a dictionary, and then you just want to get at any point of time, you just want to get some data, then it might be good to store the data in a dictionary. And at some point you just want to add something, so it depends what type of operations you want to do. Simply, data structure is a form of storing data. And what is algorithms? Algorithms, the word algorithms, it's simply it's a set of rules uh, which you follow to solve some problem. So you have a set of rules. You have a problem, you want to solve that problem. You will follow some set of rules to follow that to solve that problem. But um, uh, there are predefined problems, let's say predefined algorithms, which you can use to solve those problems. If not, then there might be a custom algorithm which you might use, you can create yourself. But the idea here is it should be um, it should be fulfilling your needs, and it should be also fulfilling your so the quality, and it should be fast, it should be space the space complexity will be less. We will talk about these things later, but in general, what should an algorithm should be is like it should be clear and unambiguous. So it should be clear and easy to understand, well defined inputs and well defined outputs. So the inputs of the algorithm should be clear, what you're going to input and what you want, what you are expecting. to understand it clearly so that you can implement that in your program easily in your. So the algorithm is just a blueprint how you're going to solve that, and then you will implement that algorithm into your language whatever you use, like C sharp, Java, C++, C, and that will be, you will be transforming that algorithm into some sort of code. So, and to do that, it should be really clear, easy to understand, and it should be language independent. So as I said, algorithms are language independent. You don't care which language you are going to use behind the scene. You just want to understand how the logic will look like, and it should be non-infinite and feasible. So it should not be going through the infinite loops, and it should be feasible, it should be doable. So these four qualities you should really notice, you should really think about before going or before writing any algorithms. So, and how do you decide for an algorithm? Yes, very good question actually, because there are plenty of algorithms. There are plenty of algorithms. We will talk about them in next videos. But how will you decide? How will you choose from them? So the part of the video, part of this answer, I will say it here. But part of the answer you will understand yourself as well. How will you decide? Or you can also comment, put your comments in the video of this video. First thing, I will really focus on look for a fit. So there are plenty of algorithms which can, let's say sorting. Let's say you are sorting some items, and there are plenty of sorting algorithms. Which one will fit for you is is on you to decide how the best fit, which one is the best fit, and then you can decide. Look also for the speed, and the speed is something, the complexity of time complexity, which we will talk in a while, which is also really important part of it. And then the third one is look for implementation, and you have the algorithm but you cannot implement it, is just hypothetical algorithm. It's not a fit, then it if it cannot be implemented, then it's nothing. So look for the feasibility as well. So till now everything is clear, I guess, right? So what we covered till now: what is data structure, clear; what is algorithm, and how do you decide to choose a best algorithm. This is the part of the answer. This is a partial part of the answer. I will you will yourself give the half or remaining answer yourself, because once you will go through all the algorithms, you should be able to decide which one is good for you. Then the next question is, what is a good code? There are two things I focus on, is first is readability and second is scalability. Good code is always, um, yeah, it can be good for me, it might not be good for someone else, because I think it's a good code because I understood it easily. I was able to do blah blah many things, but maybe someone else could not understand what I wrote. Then it's not really good code. Good code is readability. Readability means like anyone who is using your code should be able to understand what you wrote. So what logic you followed, and what logic means what algorithm you followed. And if once they know what algorithm or what logic you followed, it will be really easy to understand. um, Let me show you. So this is a code which you have here, and you see, I'm just doing some logic here. I did not put anything. Maybe you will understand, maybe you will not understand, because it is, I don't know what problem I'm solving, you don't know what problem I'm solving here. It will be really difficult for you to understand what I'm doing here, what I'm trying to do here. So in other words, if I just want to say, this is a good code, no, this is not a good code, it is doing what it is supposed to do, but it's not readable. uh, if you know the problem, what problem I'm solving, then maybe you will understand this code half, 50% of it. But still, why did I put this for loop, and why did I put this condition, if this, else this? No. And then if I try to do this is also not really clear. So this is, I cannot say this is a good code. And second is scalability. What is scalability? Scalability is your code should be ready for future. Ready for future means it's not like it should do the future work you are expecting in future, but it should be able to adapt to future. Meaning is like, let's say you had an application which was doing reservation for cars. Next year your company or your organization is also doing reservations for bikes and for big trucks. Now you need to modify your application to adapt to this new change. What you going to do? Are you really going to write down the code from scratch, or are you going to reuse your functionalities, or are you going to totally transform your UI? Because this might be, your UI and your logic might be tightly coupled, and your code might not be scalable, good enough to scale. So yeah, we have a problem here. So that is scalability. But scalability is also connected to big O. Big O, what is big O? Big O is a notation, is a generally accepted notation for complexity. So complexity is, we treat complexity is two types of complexity: time complexity and space complexity. um, so time complexity is time complexity is how much time you are taking to solve a problem, right? So how much time your application is taking. I'm really bad at writing time. And the another one is space complexity, SC, which is simply how much space your code is using, how much space is needed for your code. Let's say you have an application. Some many times you might have faced this problem, stack overflow, which is the perfect example of space complexity. Stack overflow is simply an exception you see all the time when you try to when you try to use recursion. Let's say you call the same function with the decreasing number of elements, and then you try to solve a problem. But when the number of elements, when number of number the number of times recursion increase, the time of how many times you use the recursion, if that increases, then the space complexity increases. Why? Because let's say let so you have space complexity is simply because you have, let's say, a heap. Here I will explain you what is heap. But let's say, so what happens, you have a code block function which is used by recursion, right? Recursion is calling this function every time with some new parameters, and whenever the recursion is used, this code block put a reference here in this tag, says blah blah, this part must be executed to be executed after this has done. So in the recursion, this will call this function, and this function itself, which is calling the same function, is this function itself is calling the same function with some new parameters. So what it will do, it will keep running, keep adding these type of references here, and it will wait for the last last instance to execute. Let's say this is the last instance of this to execute, so it will execute the last one, and then it will go to the next one, then it will go to the next one, then it will go to the next one, and the last one will be executed, which was the initial call for this recursion. So what happened, this heap, this will be full quickly, because if the number of recursions, so let's say you're recalling to the recursive number of recursions were proportional to the number of inputs, I mean the input n, and if the n is really high, let's say 1000, so your recursion will be called 1000 times, which will be too much space complexity. I will explain this again in real life example, but this is what happens when you use your when you see a Stack Overflow exception. So how do you measure big O? How do you calculate big O notation? How do you calculate time complexity? Let's go here. This looks really horrible. What you see here is you have order of uh, order of n log n, which is order of 1, and order of n log n. Order of 1 is kind of this line, and then you have less green line, which is order of n log n. These two algorithms are supposed to be the best if you can achieve this, and it's very rare. Then you try to compromise yourself and you try to go to um, this one then, and still this is really not that easy to achieve. Still, if you can go to still if you can achieve order of n, it's the best, still I would say. Then you go ahead and you get this order of n log n, which is covering these both areas, and then you get order of n square, which is really horrible. But this is not the end of the game. You still have order of 2 raised to n, so power of n, 2 power of n. So this goes like if you have input 3, then it goes if you have input 3, then it becomes 8, and if input is 4, then it becomes 16. So you see how fast it is increasing. But on top of it, you still have order of n factorial. I believe me, don't really want to achieve these two. Still, if you have order of n square, it's not good, it's horrible, you see, but you can compromise. So yeah, these are the type of algorithms. This might look really bad, or like might be frightening you, but slowly we will learn all these algorithms. Slowly we will go through the algorithms, and we will see these calculations, and you will understand them. It will be easy for you. So this is simple order of log n, order of n square. This is what, this is calculation of time complexity. We will then talk about these data structures in the next chapter. So what we will do is we will talk about array, stack, queue, singly linked list, double linked list. We will not talk about singly and doubly. We will talk about simple linked list. We will talk about a hash table, binary search tree, and binary tree, red black tree. We will talk about these things. We will we will not talk about KD tree. So, and we will talk about other data structures as well. And to for these specific data structures, you have some operations. How do you calculate? So this is the calculation for a specific data structure. So how do you calculate them? You have worst case, average case, and best case. So best case scenario is not really useful because in best case, well, for some time, for some operations it might be a good risk to take, because if best case might be always the best time complexity, but in the ideal situations, which is not the case in normal life. So we will focus about average case and worst case. Worst case is like you are sorting an array which is you are sorting descending and which is already sorted as ascending. So array is already sorted as ascending in ascending order, and then you are trying to sort it in descending order, and you have chosen an algorithm which is starting from the first element. So that might be really bad choice. Yeah, so that will be the worst case, like you have to go through all the elements, and this is what we are interested in actually, because yeah, this is what decides. We always take worst case and then see how our application will perform. And then you have these operations. What are the operations you have on data structure? So these are the operations you have: access, mainly actually, access, search, insertion, and deletions. Depending on your operation, what type of operations you will be performing the most, you can decide which data structure to use and which algorithm to use. So we will understand that in next sessions, but just focus on this chart. Which which uh, which uh, data structure to use depending on your problem. What is your problem? And then identify if you will be performing more access operations, search operations, insertion operations, or deletion operations. And depending on that, you can choose which data structure to use. And then to perform these operations, you need to decide which algorithm to use for that specific problem. And that will be like if you are doing more access, search, insertion, deletion again. So for array, generally access is order of n, and access here does not mean accessing a specific element, but access in array is simply getting the uh, element from index n, or anywhere wherever you want within the array range. So let's say you have an array of range 0 to 10. So you have 10 elements in the array, and you want to 0 to 10 means 11 elements actually, because array starts from 0. So you have 11 elements in the array, and you want the fifth element in the array. So you will just say blah blah array and get the fourth index, and that will be the fifth element of that array. And so that access is order of 1. And if you want to do perform a search, that will be order of n. We will see these search algorithms later on, but you see it's order of n, order of n, order of n, and these are the best algorithms. If you choose, you might have the worst algorithms, and those might be going to order of n square or something like that. So say you see you have don't doesn't matter what problem this program is solving, you see you have an integer, you have an input which is nums array, and this program is using a for loop which is running through the nums dot length, so length of this array, which let's say n, and going through this and starting at 2 and going through all the operations and doing this. So doesn't matter what logic it is doing inside here, let's calculate how many operations it will be doing. So let's say number of elements, number length of this is let's say 10. So there are 10 elements in the array. Let we go inside, we start at I equals to 2. So that means we are starting at 2, and we check if I is greater than 2, then you do this operation, else I plus plus this blah. So you, in either case you are doing one operation. So let's say we consider this as this whole thing, this whole part as one operation. Okay. So if you go through whole loop, how many operations you did? Something like if you remove this to let's say 8, so till here total 8 operations you did, and then you are doing this operation, so which might be also doing something. So I will say it is I will say this as 1. So in total let's say 9 total operations, and no, I'll say this 8 plus 1. I will explain you why. So this part is depending on the number of operations you are having, number of elements you are having in the array. So that means this operation, this will increase always, this will always increase if number of elements increase. So then I can say this is order of n minus 2, let's say, right? So this part will always take an order of n minus 2, and the last part will always take let's say 1. So this can be a constant. So you have this constant and you have this part. We always ignore the constant part, so the complexity for this whole program will be order of n minus 2 plus c, but to keep it simple we remove the constant part, we don't consider this. And then we also we don't consider this because this will be always 2, doesn't matter. Let's say it if it the number of elements in the array goes to 1000, 10,000, does 2 really matter? I don't think so. So then it becomes 9998, but for you it is always increasing if the length of length of the array increases, so we only consider this part. So this becomes what, order of n. Same way, if we go to another program, let's say move 0, what you see here is nums, and nums is having a length of n. Okay, and we return if the nums is less than 2, so this will be nothing but only one operation which will be order of 1, and this will be in best case scenario, so order of 1. And let's say what, order of 1. But then you go inside these two for loops, you have nested for loop, and you are starting I equals to n minus 2, again the order of n minus 2, but then we will not consider this part again if the number of n goes up. And then you are doing something better here, you are saying j equals to I, which means you are looping through the second loop only for less numbers. You see here, and j is less than n minus 1 and j plus plus. So you are only looping through small bit of the small chunk of the elements. But in worst case, this chunk of the element can be really big, because you are not sure what numbers. Let's say you have an worst case scenario, then you are going through the whole your chunk is too big. So this will be order of n, and then again it is, let's say in for worst case it is going for n, so this will become order of n square. Okay, so yeah, that should explain that should give you some idea how to calculate best case scenario, average, and worst case scenarios. This is it for this session, because we will be really talking a lot about these things, and we will see how it can how we can learn together data structure and algorithms. Thank you for watching. Keep liking, keep sharing and subscribing. Please like, share, and subscribe to your friends. Share to your friends as well, so that they can know it, and also it will help my channel to go, and ultimately this will give me motivation to keep making videos. This is my video after a long time, because I was not having time, but from now on, I will keep creating videos and hope to see you soon. And I hope you will keep sharing your love. Thank you. Bye. Have a nice day.